Good morning, guys. We're going to have a look at integration by nonlinear substitution today. So in the previous example, we would have just looked at something like x plus 1 or something very, very simple to the power of 3. But you can see here in this inside function, we've got x squared within that bracket. We're still going to focus on making sure that we're letting this inside function equal to u, and we're going to substitute u into here. And then we're also going to find du and substitute in terms of dx. So then we can integrate with respect to u rather than integrating with respect to x. So this is a little bit more complicated because, as you can probably guess, the derivative of this inside function is not going to be a constant. It's going to be another variable. All right, so let's get started. So let u equal to the inside function. We always let u equal to the inside function. Then we're going to find the derivative with respect to x, and that is going to be 2x. So if I rearrange this now to express in terms of dx, so I can substitute that in, this is going to become du over 2x is equal to dx. I could also write this as 1 over 2x du. So we can substitute those two values now into our equation so that we have the integral of 8x over u to the power of 3 times by 1 over 2x du. Okay, so we've still got a couple of x's to deal with here, but this is going to be a little bit simpler now because these are going to divide into each other and we're going to be left with 4 over u to the power of 3 du. And this is going to be a lot simpler to solve. So we're just going to move this 4 out the front here so that we're just finding the integral of 1 over u to the power of 3, which is the same as u to the power of negative 3. And then this is a really simple integral to find because we're just going to raise this by 1 power. We're going to divide by the new power and then we're going to add c on the end. So simplifying that now, we are left with negative 2 u, and u is equal to x squared plus 16 to the power of negative 2 plus c. We could also write this as negative 2 over x squared plus 16 to the power of 2 plus c. Okay, so that's our first simple example. I'm going to jump into the next one for you. Okay, so we've got our second example here, and we're going to do the same thing again. We're going to let the inside function equal to u. We're going to find the derivative of u with respect to x and rearrange so that we could substitute in to get rid of dx, and then we will be able to integrate with respect to u. Okay, so the first thing I'm going to do is let that inside function equal to u. So u is equal to x squared plus 3. The derivative of u with respect to x is going to be 2x, and if I rearrange that, I'm going to get du over 2x is equal to dx, which remember is just the same thing as saying 1 over 2x multiplied by du. Okay, so we can substitute into my original expression now. So we have the integral of 2x times by u, I don't need to put that in brackets, to the power of 4 times by 1 over 2x du. And again, this is really nice because these two terms are going to divide and be equal to 1. And so now I'm just going to be left with the integral of u to the power of 4 du. So it's a lot simpler to integrate this because now all I'm going to do, add 1 to the power, divide by the new power, and that's going to give me u to the power of 5 over 5 plus c, and substituting in back that original inside function, I get x squared plus 3 to the power of 5 over 5. So nice simple little examples there. I might do just one more with a little bit more complex example and then I'll finish the video off there. For this example here, I think I might use some colors just so we can sort of see what's going on. So again, we're going to take that bottom function there and we're going to let that equal to u. So x squared plus 4x plus 29 is equal to u. Now I'm going to find the derivative of u with respect to x. So that's going to give me 2x plus 4. So now we're just going to rearrange. So I'm going to multiply both sides by dx and then divide both sides by 2x plus 4. And then that is going to give me a value that I can substitute in. whoops, is equal to dx. So now I can substitute this into this part here, and I can substitute u into this part here. So let's rewrite this. So I'm going to start off with black, just so we can see what changes I've made and what I haven't done yet. Okay, and that's going to be equal to u times by times by du over 2x plus 4. All right, now I can kind of hope that you're seeing what I'm seeing here, and that's the 2x plus 4. If I factorize out that 2, I'm going to get x plus 2. So what this is really going to turn into is going to be the integral of x plus 2 over 2x plus 2 u du. And these are going to just simplify to a half. So that's actually going to be pretty simple for me now, because I'm going to find the integral of 1/2 of 1 over u du. And so when we find the integral of this is just going to be 1/2 ln u plus c. So substituting in the inside function now, this was x squared plus 4x plus 29 plus c. So a little bit more complex example, but still pretty straightforward. Alrighty guys, I'm going to leave that there. So this is just some examples of some simple familiar questions. I will probably do an example with a few more complex familiar type questions, so keep an eye out for that one. Thanks guys, talk to you soon.